The universe has always been a canvas of mystery, painted with stars that whisper secrets older than time itself. But now, something extraordinary has pierced the cosmic veil. The James Webb Space Telescope, humanity's most advanced window to the heavens, has uncovered a sight that defies belief. 4 light-years away, on the rocky exoplanet Proxima Centauri b, beams of light pulse with an eerie brilliance, like the glow of a sprawling alien metropolis. These aren't the soft flickers of distant stars or the dull heat of volcanic rock. They're sharp, rhythmic, almost deliberate, as if a civilization is broadcasting its existence across the void. This discovery has set the world ablaze, reigniting a question that has haunted us for centuries. Are we truly alone? Imagine Proxima Centauri b, a world orbiting the red dwarf star Proxima Centauri, the closest stellar neighbor to our Sun. This planet is a study in extremes, caught in a relentless cosmic dance. Its tight orbit, a mere 11.2 Earth days, locks it in a tidal embrace with its star. One side roasts under searing heat, while the other plunges into frigid darkness. Yet, it's here, on the planet's shadowed night side, that the Webb telescope glimpsed something astonishing. Flashes of light, vivid and structured, shimmer across its surface. These aren't the chaotic glints of reflected starlight or the infrared hum of barren stone. They resemble the glow of cities seen from orbit, sparking a tantalizing question. Could these be the lights of an advanced civilization, thriving in ways we can scarcely imagine? The James Webb Space Telescope, a triumph of human ingenuity, was designed to unravel the universe's deepest enigmas. Its golden honeycomb mirrors, spanning wider than a house, capture light that's traveled billions of years to reach us. But its true power lies in its infrared vision. Infrared light, invisible to our eyes, reveals the heat and energy of distant worlds, peeling back layers of cosmic mystery. When Webb turned its gaze to Proxima Centauri b, it didn't just see a planet, it saw a puzzle. The planet's night side, which should be cloaked in darkness, was alive with faint but unmistakable signals. These lights, pulsing in a narrow frequency range, don't match the natural emissions of stars or lifeless rocks. There's something else, something that has astronomers buzzing with anticipation. David Kipping, an astronomer at Columbia University, describes Proxima Centauri b as intricately unique. Most rocky planets follow a predictable pattern. They absorb sunlight and radiate it back as infrared energy. But this planet defies the norm. Its volatile host star, Proxima Centauri, is a red dwarf prone to violent flares that bathe the planet in radiation. This dynamic relationship creates an environment unlike any we've studied before. The planet's rapid orbit swings it through cycles of scorching days and freezing nights. If it lacks an atmosphere, the temperature swings could be brutal, hundreds of degrees from blazing heat to bone-chilling cold. Yet, the presence of these mysterious lights suggests something more complex. Could an atmosphere, or even advanced technology, be tempering this alien world's extremes? The implications are nothing short of staggering. For millennia, humanity has looked to the stars, dreaming of other beings. From ancient tales of sky gods to modern searches for radio signals, the idea of extraterrestrial life has captivated us. Now, Webb's discovery feels like a seismic shift. If these lights are artificial, they could be the first concrete evidence of an intelligent civilization. Picture a society so advanced it illuminates a planet's dark side, perhaps with energy sources beyond our comprehension. Are these lights from sprawling cities? Beacons meant to signal across the stars? Or something so alien we lack the framework to understand it? The possibilities ignite the imagination, sending ripples of excitement through labs, classrooms, and living rooms worldwide. Webb's role in this discovery is monumental. Unlike traditional telescopes, which falter in the face of cosmic darkness, Webb excels at capturing the faintest glimmers. Its infrared sensitivity allows it to study Proxima Centauri b even when the planet's night side faces Earth. By analyzing the light's specific frequencies, scientists can unravel its origins. Natural phenomena like auroras or volcanic glows produce broad-spectrum light, but the signals from Proxima Centauri b are narrower, more focused, hinting at something engineered. It's not definitive proof of aliens. Not yet. but it's enough to make even the most cautious researchers pause and wonder. Proxima Centauri b itself is a cosmic enigma. It orbits in the habitable zone of its star, where temperatures might allow liquid water to exist, a key ingredient for life as we know it. But its environment is harsh. The red dwarf's flares bombard the planet with radiation, and its tidal locking likely creates a stark divide between its day and night sides. If it has an atmosphere, it could redistribute heat, softening the extremes and creating conditions suitable for life. Webb's infrared data offers a glimpse into this atmosphere, revealing thermal emissions that hint at its composition. Scientists are now racing to detect key molecules, water vapor, methane, carbon dioxide, that could signal a life-friendly world. Even ozone, a marker of atmospheric stability, is within Webb's grasp. But Webb has its limits. While it's unparalleled at detecting water vapor, methane, and carbon dioxide, it struggles to identify free oxygen, a hallmark of biological activity. Oxygen is elusive, often bound in compounds or produced by non-living processes. Still, the telescope's data is a goldmine. Every flicker of light, every shift in infrared, brings us closer to understanding Proxima Centauri b. And because Webb's orbit around Earth aligns with the planet's 11.2-day cycle, it can observe the planet's day and night phases repeatedly, building a detailed portrait over time. This discovery has unleashed a torrent of scientific ambition. Researchers are planning follow-up observations with Webb, aiming to zoom in on the planet's atmosphere with unprecedented precision. They want to confirm the light's existence and uncover their source. Could they be reflections from vast solar arrays? Bioluminescent organisms glowing in alien oceans? Or something mundane, like crystalline minerals catching starlight? Each possibility is a thread in a cosmic tapestry, and Webb is the needle weaving them together. The telescope's ability to analyze infrared wavelengths is critical, as it reveals not just the planet's surface but the chemical makeup of its atmosphere, offering clues to its potential habitability. The discovery also underscores the limits of our current technology. Webb is extraordinary, but it's just one piece of the puzzle. To dive deeper, scientists are looking to ground-based observatories like the Extremely Large Telescope, set to begin operations in 2028. The ELT will offer sharper, more precise data on exoplanet atmospheres, complementing Webb's space-based observations. But the real revolution lies in the future. Imagine a telescope paired with a star shade, a massive, flower-shaped spacecraft that blocks starlight before it reaches the lens. Positioned tens of thousands of kilometers away, the star shade would allow the telescope to see only the faint light of planets, revealing their surfaces, climates, and even potential biosignatures in stunning detail. Another promising technology is the coronagraph, a device inside telescopes that dims starlight to highlight planets. Stars are blindingly bright, often drowning out the faint glow of their orbiting worlds. Coronagraphs manipulate light waves to reduce this glare, making planets stand out like fireflies against the night. These innovations are no small feat. Aligning a star shade requires precision to fractions of a millimeter across vast distances. Coronagraphs demand flawless optics to filter out a star's overwhelming brilliance. Yet the rewards are immense. By studying the light that filters through a planet's atmosphere, scientists can detect biosignatures, chemicals like methane, oxygen, or water vapor in ratios that suggest life. A planet with the right balance of these molecules could be a living world, teeming with organisms or even civilizations. The lights on Proxima Centauri b are more than a scientific curiosity. They're a glimpse into the past. The light we see today left the planet 4 years ago, a snapshot of history traveling across the stars. If those lights are artificial, they've been shining for years, waiting for our technology to evolve. It's a humbling thought. Somewhere out there, a civilization might be gazing back at Earth, wondering if our own faint lights, our cities, our satellites, mean they're not alone. This cosmic time machine, powered by Webb's mirrors, shows us the universe as it was, not as it is, adding a layer of wonder to every observation. Proxima Centauri, as our closest stellar neighbor, has long been a focal point for exploration. Scientists have studied it for decades, dreaming of finding life. But the notion of spotting artificial lights, of seeing evidence of intelligence, was the stuff of science fiction until now. Webb's data is rewriting the narrative, turning dreams into possibilities. With every observation, we're peeling back the layers of this alien world, learning its secrets one photon at a time. And Proxima Centauri b is just the beginning. Webb is scanning dozens of exoplanets, searching for the chemical fingerprints of habitability. Methane in the right amounts could point to microbial life. Carbon dioxide might suggest a stable atmosphere. Water vapor could mean oceans, rivers, or clouds. These aren't just molecules. They're clues to worlds that might mirror Earth or defy our wildest expectations. What makes this moment so electrifying is its uncertainty. The lights on Proxima Centauri b could be a mirage, a natural phenomenon we don't yet understand. Or they could be the first glimpse of something profound, a civilization that's been there all along, hidden in plain sight. Either way, the James Webb Space Telescope is rewriting the rules. It's not just a machine, it's a bridge to the unknown, carrying us closer to answers we've sought for millennia. Its data is fueling a new era of discovery, one where the boundaries between science fiction and reality blur. Imagine the day we confirm those lights are real. Picture the headlines screaming across the globe, the debates erupting in lecture halls and coffee shops, the wonder rippling through every corner of society. A single discovery could reshape our place in the cosmos, proving we're part of a larger story. It could inspire generations to look skyward, to dream bigger, to reach further. For now, we wait, watch, and wonder. The universe is vast, but it's no longer silent. Somewhere out there, in the glow of an alien night, a signal is shining. And thanks to the James Webb Space Telescope, we're finally starting to see it. This discovery is a spark, a flare in the darkness that invites us to keep searching. The hunt for life isn't just about Proxima Centauri b, it's about every distant world, every faint signal, every possibility. Webb is our guide, but the journey is humanity's. As we analyze its data, plan new missions, and build bolder technologies, we're drawing closer to answering the ultimate question: is there life beyond Earth? The lights on Proxima Centauri b are a reminder that the universe is full of surprises, waiting for us to find them. And with every step, we're writing a new chapter in the story of our place among the stars.